We're going to continue on with our work with conic sections, and in this lesson we're going to talk about parabolas. You're going to be given a formula sheet that has all of the following information on it, so you don't have to write all of this in your notes unless you just want to. All of this information will be on the formula sheet that you're going to be given. One correction or one thing that I would like for you to know, this PowerPoint, which has some great examples, uses a letter for a certain representation. It uses the letter A, where your formula sheet is going to use the letter P. P is the most common letter that's used when we're talking about parabolas and when we're looking at these formulas. So P is what we're going to use, but if you write this down in your notes, you're going to need to somehow in there make sure that you're aware that where this information uses A, that we're actually going to be using P when we do homework and quizzes and exams. So here are a couple of equations and vertices and focus points for different types of parabolas. And according to the form of the equation, we can get the information we need from it to talk about the vertex point, the focus point, the directrix line, and the line of symmetry. So let's take a look at this. Here we have a squared y term, and we have an x term that is to 1 degree. So the vertex for this is hk. The x-coordinate to the vertex is h, which is found right here in the equation. And the y-coordinate for the vertex is k, which is found right there. And the focus point is h, the x-coordinate, plus a, this value right here, which when we factor it out of x minus h, that's actually, again, like I say, the letter P on your formula sheet. But we can find the focus point by taking the x-coordinate of our vertex and adding that value of P. And then the y-coordinate to our focus for this type of parabola is just K. The directrix is a vertical line, and that vertical line is H minus A. The line of symmetry for this parabola is going to be parallel to the x-axis, and this parabola will open to the right. Now, what we look at to see that it opens to the right is that this value a, or again for us it's going to be the value of p, that it is a positive value. When it is positive and the y-coordinate is squared while the x-coordinate is to degree 1, that is a parabola that opens to the right. Here you can see the difference between these two equations is this negative sign right here. When there's a negative out front, it affects some things along for that parabola. The vertex is still at the point HK. Again, here's where we find H, here's where we find K. We can see that we still have a squared y value where our x value is to degree 1. Now for this one, the focus is found by taking H and subtracting the value of A. That's going to be the x-coordinate of the focus point, and then the y-coordinate is still just the same y-coordinate as the vertex. The line, the vertical line that is the directrix for this parabola, is going to be our x-coordinate of our vertex point plus the distance A. The line of symmetry, again, will be parallel to the x-axis, and this will be a parabola that opens to the left. So here graphically is what it will look like. Here we have a parabola that opens to the right. We can see that here is the vertex point HK. The focus, which is inside the parabola always, so if the parabola opens to the right, the focus should be a point that's to the right of the vertex. The directrix is going to be this line, x equals h minus a, and the axis of symmetry is going to be the line y equals k. For the parabola that opens to the left, since the focus point is inside the parabola, we should expect the focus point to be to the left of the vertex. The vertex again is the point hk. The axis of symmetry is the horizontal line y equals k, and the directrix is the vertical line x equals h plus a. So according to the form that we have down here for these parabolas, it gives us all this information. So being given the equation of the parabola, we could fairly easily draw a graph of that parabola. Now, there are other parabolas. These we're more comfortable with. These are the ones that open up or down. So if we see an x term that's squared and a y term to a power of 1, we know we're dealing with a parabola that opens up or down. And you can guess if this coefficient is positive, then that parabola is going to open up. If it's negative, then that parabola is going to open down. The vertex, still very easy to find. It's the point HK. The focus now is going to be a value added to your y coordinate, because if we open up or down, the focus is going to be inside that parabola, which means the focus is going to be above or below that vertex point, where on the last set we saw that it was to the left or to the right of the vertex point. So now if we open up, we're going to have a focus point that is H, the same x coordinate as the vertex, but we're going to take the y coordinate of the vertex point and we're going to add that value of a, or like I say, for us it's going to be p. The directrix is going to be the line y equals k minus a. The line of symmetry is going to be parallel to the y-axis, and again, as I said, this is a parabola that opens up. Here's what it looks like for a parabola to open down. That negative sign means we're going to open down. Vertex is still at HK. Focus is at H, K minus A. The directrix is the line y equals k plus a, and the line of symmetry is parallel to the y-axis. It's a vertical line, and this is, again, a parabola that opens down. So there visually we can see graphically what all of this information in the table gives us. Here's our vertex point, HK, for a parabola that opens up. The focus is going to be above the vertex, so that's k plus a. The directrix is going to be below the vertex, so that's k minus a. The line of symmetry is going to contain the vertex point, so that line is going to be the vertical line x equals h. For a parabola that opens down, the vertex is still hk, the focus is going to be below it, so it's k minus a. The directrix is going to be above it, so it's k plus a, and the line of symmetry is going to be a vertical line that contains the vertex, so that's the vertical line x equals h. Once again, we can get all of that information from the actual equation if they give us the equation. But also, if they give us some of this information, we can take this information and we could find the equation of the parabola that they're referring to. So here it says find the vertex, the focus, the directrix, and the latus rectum for each equation. We won't worry much about latus rectum, but I'll show you on this example. It's just included in here, but it's not something we're going to worry a whole lot about. So here's one where the x term is squared and the y term is to a power of 1. So this is a parabola that either opens up or opens down. We can see here there's no negative sign in front of the y, so this is a parabola that opens up. The vertex, there is no x minus or y minus, therefore h has to be 0 and k has to be 0, so the vertex point is at 0, 0. We know that we need to find a, so we have x squared equals 4 times a times y, so 4a equals 16, therefore a has to equal 4, and it's a positive 4, so again we know that it opens up. To find the focus point, which is going to be inside this parabola, we know that the focus point is going to have to be above a distance of a, above that vertex point. So our vertex is 0, 4. We're going vertically up a distance of 4, so the focus should be at 0, 4. If we want to find the directrix, the line that is the directrix, it's going to be equidistant down here below that vertex point, and it's going to be a horizontal line, y equals k minus a. So that's the horizontal line, y equals -4. That's going to be our directrix. Now it didn't ask for the line of symmetry, but the vertical line x equals 0 will be our line of symmetry because it is the vertical line that contains the vertex point, and the x-coordinate of that vertex point is 0. The latus rectum, excuse me, is we're going to plug the value here. That is our focus. We'll plug that value in for y, and we'll find the corresponding x values for that, and so those 2 points will lie on the latus rectum. All right, let's work another equation or another example. Find the equation given. The focus is 0, -2, and the directrix is x equal to. So we know the focus, it's down below the point of origin, and we know the directrix. We know the focus is always inside the parabola, and we know that the directrix is, I guess we would say, perpendicular to how that the parabola opens. So we're going to be opening to the left. So we know that x equals 2 is the directrix, and so therefore a has to equal 1. The vertex point is going to be between the focus and the directrix, so it is the point 1, -2. It's equidistant from the focus, the vertex is from the focus and the directrix, remember, and the distance from the vertex to the directrix is the distance of A. The distance from the focus to the vertex is also the distance A. So we know it opens to the left because the focus is inside. So we have our vertex point, so we know that H is 1 and K is -2. We are opening to the left, so we know that we have a -4 in front of that A value. So we're going to plug in those values, and there it is. There is the equation of the parabola given the focus and the directrix. Find the equation given the vertex and the focus. So the vertex is the point 3,1, the focus is the point 3,5, so that the vertex and the focus lay on the same vertical line. I know the focus is inside the parabola, so this is a parabola that's going to open up. And so I know I'm going to have an x squared term. I know I'm going to have a single degree y term. I know we open up, so that 4 times a is going to be positive. So lots of information that I can find there. So remember that the distance a is equidistant from the vertex to the focus and equidistant from the vertex to the directrix. So this distance, 1, 2, 3, 4, is going to be A. And I have H equals 3 and K equals 1. I know that I open up, so that is a positive 4 times A, and there's the equation for that parabola. The directrix, equidistant, it is a line that's 4 units below that vertex point, so 1 minus 4, it is the horizontal line y equals -3. Find the vertex and the focus given this equation of a parabola. This, just like the circle, is not in vertex form, so we're going to have to use complete the square to get it into vertex form. So we're going to gather our y terms, gather our x terms, complete the square, and we see that we have y plus 5 quantity squared equals -x plus 5. So we're going to have to factor that negative out. And so what is written here is -4 times a. So we can actually find the vertex and the focus from that information. We know that it opens left because of that negative sign. The vertex is right there in front of us. It is 5, -5. We know that -4a equals -1. So 1 equals 4a, a equals 1/4. The focus, which is going to be inside our parabola, is going to be a distance of a to the left of our vertex point, where the directrix is a distance of a to the right of our vertex point. And so there we have it. There's the focus. So that's it. I know that was quick, but it's a lot easier to do in practice than it is to explain. Come to class next time. I'll give you the formula sheet and we'll practice graphing these parabolas and completing the square and working with these conic sections.